So this is an exercise again. We're going to do some low pass filtering. You have to program a filter and test it. And this is going to be a simulation exercise. So in this template project there will be a simulator that you can use to verify the program that you made. So if we have a little look at the exercise 2 here. So of course, 4 students or something, 4 people, do it by yourself, it doesn't matter. What's important here is you understand what you're doing. So in here there's some emulators. The Signal emulator is an instant making a Signal simulator. The program this is all pre-programmed, and so what you have to program is this first order exponential filter. It is in the template project, so I've called it just IMP, import, or you get hold of it, or write it, or write it in Visual Studio Code and paste it in, or no matter. In the exercise also call for scaling of an input, and then there's a program here that you should call these instances and organize it, and which this has to be called in main, again indicating here there is in this template projects down here there is on the video something called PRG main, which is linked to a task in the project. So here's just an overview. So the purpose here, a low pass filter function, structured text, SCL, that's all we are programmed here. Then how to use the trace function, and how to use a low pass filter to remove superimposed noise from a signal. And the noise in the emulator is deterministic, a sinusoidal noise and a random noise. So program the exponential function block that we have to do, instantiate the function block, test the filter, and generate a time series plot, a trace it's called in Bismatic, and calculate the damping ratio, the dB calculation. So it is copied to this document and document handled in or something. If you want to prove, if you're doing this all by yourself because you have seen the video or something, whatever, on YouTube, you will not have anything to hand in. But what you need is a PC with TI portal and a PLC simulator, or a real CPU if you don't have the simulator. But if you have TI portal, you have the simulator too. So what you need is basically your PC, preferably a couple of screens when you do programming. Doing program a 10-inch or 12, 13-inch screen on a laptop, that's challenging. So if you want to do serious programming in any language, you need more than one screen, or maybe a curved 49-inch screen or whatever, but you need something to look at. The programming, first order low pass filter you should program. You make an instance, it's suggested what you should call them. Just keep these names, and this is the exercise 1 in main that has to be called in main, and so on. Yeah, and here is there is in the tag table, in the PLC tag table, if you open that in the project, you're going to find something called PT01, pressure transmitter 01. So let's say it's a pressure we have in here. So that's the signal generator. We can input it here. We can input it directly into the filter and trace it. Here's the trace that you have to make and download. And here is the program main of what we are looking at. This IDB low pass filter you have made that you can supervise online. Here's a suggestion, and again too, how to make it in this compendium that we are using. Here is a pseudocode for it, and here is the suggested parameter use that you have, and there's a little description or maybe how to program in the pseudocode. So how to do this, you need sampling. And as this is working on previous calculated values and current values, we use these indexes k, and this should be the k minus 1, which is what it calculated last time on my input last time if I need it. But this being a first order system, I don't need past values for my input, but I need one past value for first order function for my output that I'm doing to calculate. And here is some for scratch purposes if you need that, and the timing system, which is also in the compendium, how to make a timing system. time constant, and here is also substitute value. There is a function in the template that validates a floating point 32-bit number or a long real if you opt to make a long real filter with 64 bits. A long real value is a double. It's also known 64-bit floating point. A real is a single, which is a 32-bit floating point, IEEE format floating point. Okay. So what you should do, export the code, document it or screenshot or something, document what you have been programming and how you have set it up in this program main. And what you have to put into program main is pretty much this, but you also need an instance here of an analog block that is in the library just to scale this input. So that's an input. Testing, make an instance data block of this one. And here too, make a trace function. Here's a suggestion for the configuration of the trace function. There are help files in TI portal or help system. Look in there how to make a trace, or just go down in the tree view and find the trace, make a new trace, and see how you can work with a trace. You can use drag and drop or things like that. So here's how to test it, and here are some suggestions to the noise signals and so on. Okay, so this is in the simulation or part of the simulator, how to switch them on. And this is also on the screen, so you can manipulate this. And here's some suggestion how to set this. But you can use whatever you want, slower signals or high-speed signals or whatever. And then you should also do some dB calculation here. And what you should hand in is a screenshot of the trace plot that you have tested it and it's working. Make a plot yourself and borrow one from your neighbor, at least, and understand how he did it. And a dB calculation. Signal, noise signal. And any comments for 6 and 7? Yeah. So it's basically, this is not a rigorous filter test to calculating cutoff frequency or something like this. It's just a test in this function block and instance of the function you made, but feel free to do calculation of cutoff frequency. It is possible. Here is how you could calculate this dB, or you can use this cursors here, the horizontal cursors, to find the amplitudes of the signals that you have. This is the input filter, output filter. And if you don't see these values, there's a trace in the upper right-hand corner in TI portal. When you are in a trace view, where you can look at the values in the trace with, I think, the 6 decimals or something like that. This is the peak-to-peak values. Of course, the amplitude in theory, but peak-to-peak for sinusoid signal like this is just a double of the amplitude. So you can go to peak-to-peak if you want. And here again, the signal model has the following instance block where you can manipulate sampling time for all of this signal. The maximum, this is the maximum for the schematic analog format in here. And what is Excel? This should be, I'm going to remove this. This is the next exercise. Has nothing to do with this exercise. This is the general rate of signals that you're filtering. The Y1 here is the real output. That's what should be in here. So I'm going to fix that. What inputs are used by the model, blah, 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 and so on. And here is a little information about these parameters in this PIF parameter, switches or something. And so on. And here is the screen. If you open the emulator screen in this template project, and here's what you can do to the screen. So then you can manipulate, switch on and off with the screen, and if you want to, you can put your filter, maybe even the parameters over here, and I've made a curve here. This curve is going to be in the template project, so if you want to make something yourself, you can make a copy of this one, and then change the input in this trace here if you want to. But the assignment here is PLC programming. not HMI programming, because preferably we would use another HMI for your system on a PC system or something like that. So this is made for comfort panel. We could use a unified panel for this, and Java scripting and all this stuff, but that's kind of time consuming and expensive to make something like this. That was something I would have to fix here. So that was an introduction to the first simulation exercise, where we have an emulator or simulator in this template projects that we have, which can generate noise. So say first a signal, it's a sinusoid, and a deterministic noise, which is another sinusoid, and then some random noise, and then test the filter and see how your filter is performing. What you're going to notice is that the filter is going to lag. So the output from the filter is going to lag the input for the filter, and that's kind of logical because you have to do some calculations and output that. So that's not going to take place at the same time as you get input, and especially not before you get input. So it's going to be after. So it's lagging the output. That's something that you are going to notice.